Okay, ladies and gentlemen, thank you so much for registering for our webinar this afternoon, the Unlocking Offshore Wind Opportunities in Taiwan. Now, we are very excited to have you all here with us today. We have a fantastic lineup of speakers from the industry and also from the academic section to share with us valuable insights, experiences, and hopefully gain some opportunities in the offshore wind industry here in Taiwan. And we'll be more than happy to engage with you. So a little bit about myself. My name is David. I am the representative of the World Forum Offshore Wind here in Taiwan. We are very excited to start shop here since July this year. I will let my managing director to share with us a little bit more about what we do, and he'll be more than happy to share in a broader context of the offshore wind industry at the moment throughout the world. Now, we have some very special guests today. We have actually invited the Director General of the Bureau of Energy. Unfortunately, at the moment, he's engaged in a meeting, so he will try his best to come to our program a little bit later this afternoon. If he makes it, we'll be more than happy to have him on board to share with us his thoughts, and also maybe just a little bit about the agenda that the Bureau of Energy has in regards to offshore wind. So very happy. Without further ado, if I may, I will start off with the first speaker, which is going to be addressing to us and welcome us on the overview of the offshore wind industry from the World Forum Offshore Wind, and that is my Managing Director, Mr. Gunnar Hesek. So Gunnar, the floor is yours. Thank you very much.
Great. Thank you very much, David, for the very kind introduction. Very excited to be part of this webinar about unlocking offshore wind opportunities in Taiwan. And as David said, my name is Gunnar Hesek. I'm the Managing Director of the World Forum Offshore Wind, or WFO in short. And it's my great pleasure to be talking about global offshore wind today. And so what I will say is based on our latest report, the Global Offshore Wind Report, which is the half-year update for 2021. And let me just start with a few quick words about our organization, the World Forum Offshore Wind. So we are a non-profit organization, still comparatively young, founded in 2018, and focusing exclusively on offshore wind, so nothing else, offshore wind only. And our members represent the complete offshore wind value chain, including utilities, manufacturers, service firms from around the world, so really covering every type of business from around the globe. And we have an international setup as an organization now with 4 offices in Hamburg, Taipei, Tokyo, and New York. And in terms of activities, what we do, it's very straightforward. It's 3 things. We advise policymakers and regulators with regards to offshore wind in various countries around the world. We inform the global offshore wind community and the general public about the latest offshore wind developments. And we connect the industry and players from around the world via our events, whether it's conferences, committees, workshops, to make sure that people exchange their views and talk to each other. And just to highlight one of our committees, that's actually our Floating Offshore Wind Committee. Since floating offshore wind has become such a dynamic and fast-growing area of the offshore wind industry, we decided last year to create our very focused Floating Offshore Wind Committee, which has a very straightforward structure. We have a main or general Floating Offshore Wind Committee meeting, which meets on a quarterly basis. And in addition to that, we have 3 dedicated subcommittees meeting on a monthly basis on very specific topics. So talking about insurance and insurability for floating offshore wind, mooring systems, or O&M, everything specifically concerning floating offshore wind. And that is actually a very dynamic forum where our members discuss things, exchange the latest ideas and developments. And that's really something we're very proud of, that by now we have a very dynamic structure in place to make sure we push for more floating offshore wind around the world. And then if we go to the next slide, you can just see a quick overview of our members, indeed ranging from utilities from around the world, component manufacturers, service firms, law firms, so all kind of parts of the industry. And if you are not a member of WFO yet, please feel free to check out our website, and we're always grateful for any new members joining our organization. So if we now have a look at the global operational offshore wind capacity, we have the latest figures from our half-year 1 report, end of half-year 2021, and we can see that by the end of June of this year, the global capacity has reached roughly 30 or slightly above 34 gigawatts, and in total 169 offshore wind farms are now operational in Europe, Asia, and the USA. And on the next slide, we can actually see in more detail where all this capacity is installed. So the UK is still the leading offshore wind country when it comes to installed capacity, with slightly over 10 gigawatts of operational capacity. But Taiwan is actually already in 7th place with its dynamic build out over the past couple of years. And as you know, only in June actually of this year, the second commercial scale project in Taiwan, the Changhua Phase 1 project with 109 megawatts, has been successfully installed, and that now brings Taiwan to a total capacity of 237 megawatts, which is already in 7th place, and I'm sure we'll see more progress, especially if we consider what's currently under construction. And on the next slide, we can actually see capacity under construction, and here we see that Taiwan is even more prominently featured because it's actually in 3rd place from a global point of view. And we can see that Taiwan currently has 640 megawatts under construction and is even ahead of other prominent offshore wind countries like the Netherlands. And therefore, we can really see this dynamic growth trajectory that Taiwan is on, and that really places it among the top offshore wind markets globally. And we can actually also see that kind of regulatory disruptions do cause some trouble in Germany, for example, where the government some time ago decided to switch from a feed-in tariff to a competitive auction model. We now realize that this created a bit of a gap in the build-out of offshore wind, and therefore Germany currently does not have anything under construction, and only later this year we will see the first projects going into construction again. But this just kind of highlights the difficulties that regulatory changes can cause if you kind of don't closely align any change or allow gaps to be left in your offshore wind pipeline. That can then create some years without anything being constructed, which is always quite tricky for the supply chain. So ideally something to be avoided, and luckily something we don't see in Taiwan with this nice continuous pipeline of projects. And that already brings us to the next slide. So any more detailed information or all those statistics I just showed, you can find in our Global Offshore Wind Report, which is available for free on our website. And please feel free to check it out. And that's really it from my side for today. So thank you very much for listening. Great to be part of this webinar. And David, back to you. Thank you very much.
Okay, thank you so much, Gunnar, for that presentation. So Taiwan actually have such a great potential for developing offshore wind, and we have quite an ambitious goal, I would say, if you don't mind, with targeting set for 2025 and also the upcoming round for the next phase. So that's very interesting to learn. And so thank you so much for that. Now, it is with my great pleasure to actually invite Mr. Chong from RWE here in Taiwan. Mr. Chong is the general manager for the offshore wind industry, offshore wind section here in Taiwan, and he'll be addressing to us about how to make the most out of offshore wind. So, Mr. Chong, if you're ready, the floor is all yours. Thank you very much. Okay. Hello, Mr. Chong. Are you still with us? Okay, I think we may be, oh, here we go. Okay, it's coming up now. So the floor is yours, Mr. Chong. Thank you. Your microphone seems to be off at the moment.
Okay, can you hear me now?
Yes, loud and clear. Thank you.
Brilliant. Okay, sorry about that. The fallacies of online seminars. So heading back to my screen. So this is today I've been asked to talk about the making the most of offshore wind. So today I'm going to be talking about 4 key things. Firstly, a quick introduction to RWE for those of you who don't know us. Secondly, a quick introduction to why offshore wind. Why all of a sudden is offshore wind the hot topic worldwide? Thirdly, a bit of a deep dive into floating offshore wind. And then fourthly, talking about new innovations which we are investing in this sector. So first, I'd like to say it's a pleasure to be back with the WFO. RWE is one of the founding members, and I remember when WFO came to Taiwan, I think it was 2 years previously, where there's a lovely seminar in the Grand Hotel, so it's good to be back. So firstly, RWE, for those of you who don't know, is one of the world's largest and oldest electricity companies. We were founded over 120 years ago and now have 43 gigawatts of generation capacity in operation, starting in standard fossil fuel generation from coal, gas, moving into nuclear and then renewables, and now investing into new technologies as well, so offshore wind, onshore wind, solar.
So I think we're having a bit of a lag with the connection. All right, ladies and gentlemen, so that is the what we have when we have an online event. So it's inevitable that we have some disconnections in between, but please do bear with us. Mr. Chung, are you back with us?
Yes, can you hear me?
Okay, we can hear you now. Thank you very much.
Apologies about this connection. So firstly, the next section is talking about why is offshore wind so popular, and then starting in a global context and moving to Taiwan. So the reason why offshore wind has become really popular in the last few years is because it offers the potential for large-scale generation, which is zero carbon and price competitive. Until the last few years, to have zero carbon electricity generation was very difficult, especially at the scales at which we now see today. But now offshore wind are offering not just hundreds of megawatts, but gigawatt scale capacities, which are large enough to replace coal and nuclear. So really offering a way for a sustainable low carbon future, and also one which is price competitive against conventional technologies. So no longer do we need to pay a premium for renewable energy. It can actually be done at a price level which is actually similar, if not more cheaper than standard technologies. Now, conventionally, offshore wind has needed 3 things to succeed. Firstly, good wind. Secondly, shallow waters. And thirdly, proximity to demand. And these 3 things you have in the past restricted offshore wind development to certain areas, which on the map, which you can see on this side, is highlighted, circled in red. However, this brings me on to my next topic, which is floating allows the second of these constraints to be removed. So by removing the need for shallow waters, suddenly you can tap into a whole lot of areas and produce large-scale electricity. So, next slide. In the Taiwan context, this is a slide which I'm sure those of you familiar with Taiwan would have seen before. This shows the wind resource potential for Taiwan, and here we see strong winds clustered in the northwest of Taiwan due to the central mountain range which runs in the northwest direction through the island. And this concentrates the wind, so you have greatest wind yields in the northwest. But you can see that a lot of this is actually in waters which are deeper than 50 meters, so areas which were previously accessible to fixed bottom offshore wind. And also benefits about the northwest area is it's also close to the centres of high demand. So this areas such as Taipei, such as Hsinchu, where the semiconductor industry is based, is all close to these wind resources. So what floating would allow Taiwan to do is to tap into these strong wind resources, which are further from coast, beyond water depths, heading down to 90-meter water depths, and so to tap into this massive potential. So in terms of floating technology itself, where we are in the world is we see there are several demonstrator projects which have been invested in, not only by RWE but other companies. As you can see from the example on this slide here, there are different types of technologies. Actually, currently there are over 50 different types of floating combinations. This is a combination of floater as well as mooring systems. And you will see here, our view internally is there will be no one-size-fits-all solution. Different sites have different conditions, different water depths, different soil conditions, and they need different technology answers to optimize the sites. So what we've done at RWE is invest in different demonstrator projects using different technologies. And the goal here is to take these learnings so that when we come to a new site, we can then use the best combination technologies to deploy in those areas to help bring down the cost of electricity. Even though the three demonstrators we've invested in look different, actually they do have one thing in common, which is they all use modular design, and this is key. In this slide here, it shows the key to success for floating offshore wind is about mass production. In order to create commercial scale offshore wind, floating wind farms, you need to install around 30 to 60 units a year. So here the design needs to allow the mass production of units. The design needs to consider constraints such as port infrastructure, such as manufacturing capability. And this is where we see modular design being key. So there are many demonstrators today which you can make one or two of them, that's good, but can you make 50 of them? Because that's what's going to be key. So the next steps for the industry are going to be what we see is investment in pre-commercial pilot projects. So these are projects of around 100 megawatts plus, which can help bring down the costs and establish the supply chain. So to demonstrate this, what we see is to hit the goal of commercial scale projects. First step one are demonstrator projects to prove that the technology works, but this has already been proven feasible. The current focus are these pre-commercial projects. You call them pilot projects of scale 100 megawatt plus. And this is really important to allow the supply chain, the local supply chain, to have that stepping stone to invest into their technologies, into their factories at a scale which is still feasible, but then allows the cost down to happen, because ultimately this industry can only take off if both the supply chain as well as banks, lenders, having faith in this and seeing from results that prices coming down and that projects are being deployed. Only after that will we see commercial scale projects being deployed on a worldwide basis. So that's my deep dive into floating. In the next two slides, I want to talk a bit about future innovations. Sorry. So firstly, green hydrogen. This is an area which at RWE we are investing heavily into. We see the potential here of green hydrogen to unlock the industry even further. Currently, one of the constraints of offshore wind is the successes that we can deploy at large scale. The difficulty would be how an electricity system can offtake a large amount of variable generation of electricity. And so instead of outputting electricity, one way to convert it at source into other energy forms such as hydrogen. This then can be exported into the system, exported internationally and sold, or converted into other fuel stock. And the key thing about this is actually within industry, there are certain industrial processes which are not electrified. So it's actually hard to decarbonize it by green electricity. But through green hydrogen, it is possible then to decarbonize industrial processes. Another technology I want to quickly mention is airborne wind energy. At RW, we invest a lot into research and development, into new prospective technologies, and this is an area which we are looking at as well. The concept is simple. It's still at research stage, but in terms of making the most out of offshore wind, the concept is to take the most efficient part of a turbine, which is the tips of the blades, then remove the heavy infrastructure, the towers and nacelles, and that in turn removes the need for the really expensive offshore installation vessels, and then to use that to generate the electricity. So there's one test site we've invested in Ireland, which is designed to prove this technology at a demonstrator scale. So this is where you have the kite, which connected to a tethered winch, which effectively draws on the wind currents, pulls itself out, generating electricity, and then using a fraction of the electricity made, then pulls itself back in and repeats. And the reason why this has potential is because it removes the heavy infrastructure required, and that is associated with offshore wind, so potentially reducing the levelized cost of electricity. So my last slide, the key message is innovations can flourish with the right conditions. I see there being three things which are required: resources, enabling regulation, and funding. So with resources, in Taiwan, it has good universities, good engineers, good heavy industry, and also all the developers already here. So I think that's already a tick in the box. With the regulation, this is important to ensure that the regulation is there which actually supports the industry and doesn't over-regulate, which was something which isn't over-prescriptive, which shuts out new innovation. So something which allows new technologies. And then lastly, importantly, funding. These technologies are still, many of them are still new and need support. So in order to allow these to establish themselves, feed-in tariff funding can help them get off the ground and help establish Taiwan as a hub for these new technologies. Thank you very much for your time. It's been a pleasure.
Thank you so much, Mr. Chong, for that very detailed and very specific insights on the markets here in Taiwan, and also the development focus with RWE, and also on what you're trying to do here in Taiwan. So thank you so much. Now, ladies and gentlemen, I have actually just received word that the Director General is online. However, I don't actually see him with our panel members. I'll just quickly shout out to my colleagues just to double check. Do you think that you actually see the Director General, Mr. Yu You, online with us? Okay. I think unfortunately we may have just lost him here, but nonetheless, we previously, when we were actually speaking to his office, he was extremely excited about this activity. So he actually tried his best to move heavens and earth to participate, but unfortunately, I think we just don't have him with us on this occasion. However, I'm sure we will have him the next time. But nonetheless, it is very exciting to actually have invited different experts of the industry to come and share with us on the insight and development of offshore wind, especially perhaps when we talk about the floating offshore wind. So it is with great pleasure to have invited Professor Jiang from NTU, of the NTU Energy Research Center from the National Taiwan University. So Professor Jiang, thank you so much for joining us today. And if you'd be so kind, we are ready for your presentation, and the floor is yours. Thank you very much.
Okay, thank you, Mr. Chairman, and for your kind introduction. And hello, everyone. My name is Maoxiong Jiang from National Taiwan University. And in the next 10 minutes, I would like to show you what we have doing, prepare for the next demand for the floating offshore wind in Taiwan. And now we have a project sponsored by the Ministry of Science and Technology and cooperate with CSBC, and Dr. Zhou, the Vice President, will also have a talk next to me. And in my talk, I would like to show you a short introduction about what we have to do and what is the next step in Taiwan for the floating offshore wind. And because since 2016 and to 2019, I have joined in the National Energy Program Phase 2, and I'm the PI of the offshore wind power. So many research and development projects are under review and control of my team. So we know the government policy, and also we are looking forward to promote the development of the offshore wind in Taiwan. So yeah, here this figure you can see in the previous talk, because in Taiwan, you know, and besides the energy transition, now we focus on the net zero emission. So the demand of the offshore wind become bigger and bigger. And so the government, the Taiwan government has announced from 2026 to 2035, another 15 gigawatt will be open and in the phase 3 zone development. And in this figure, you can also see in the deeper water area, that means that the water depth more than 50 meter actually has more potential, and is in the phase 3. Okay, the floating wind, the demand can be expected, and also the localization of the floating wind can also be expected. It is also the reason why we cooperate with CSBC company and to accelerate the local supply chain development in Taiwan. And here, as you know, in Taiwan, we have a 3 phase. Phase 1 is demonstration project, and phase 2 now. And in the previous slide, you can see now it's about 650 megawatt now in Taiwan under construction. So in the next year, phase 3 will be start to compete, and 1.5 gigawatt per year will be open. Yeah, so that means that the floating offshore wind will be in demand in the near future in Taiwan. So we have to do something to prepare for the demand. Yeah, so in the phase 3, the zonal development, besides the 4.5 gigawatt allocated in the phase 2, and more in the water depth than 50 meter will be in demand. And yeah, so the localization will also incorporate in the phase 3 to establish the self-sustaining market and the domestic supply chain. Yeah, here you can see the so-called Bible of the commitment of local supply chain. Yeah, I think that every wind farm developer knows this table in Chinese, but I translate it in English. Yeah, here you can see the foundation actually is the necessary item, and not only the bottom fixed foundation, but also in the future for the floating foundation also is a important item. So it's the reason why we would like to now in 2021 we start to promote the floating wind development in Taiwan. Yeah. In this slide, you can see our team in NTU, National Taiwan University. Besides me, and we have 6 different different professors in different areas, and including Professor Yang, Sun Han Yang, Professor Xiu Zhao, and Katie Ma, and Jifa Cai, and Hong Yue Luo, and Zhong Hong Lin. Yeah, and I will have a short introduction later in my talk. And besides that, we also have the main partner of our team is CSBC, and besides that, we have a MOU with CDWE, Taiwan, and SOIC is also an important partner for us for the platform design, and also we want to develop the CIP. And we also have an international linkage like Stuttgart Wind, Professor Borenzen, and in Chalmers University in Sweden, TNO, and Strathclyde University in UK. yeah, here is my CV. I'm coordinator for the project and also responsible for the sub project 1. In this project, we were focused on the dynamic analysis and the control of a 15 megawatt semi-submersible floating offshore wind in Taiwan. As you know, in Taiwan, in the Taiwan Strait, actually, the water depths are between 50 to 100 meters. So semi-submersible maybe is a suitable platform for Taiwan, and its condition actually is quite similar to the King Garden in Scotland. So in this project, we would like to have develop the couple aero hydro servo elastic dynamic simulation of our system, because we need to develop our own evaluation ability and to know what kind of the platform and the combination of the platform and the wind turbine is suitable for Taiwan. So it's the main topic of the sub project. And you can see besides the modeling and the wind and the wave analysis is also important for the site suitable for the floating offshore wind in Taiwan. So we also would like to have to investigate a suitable test site for the near future in Taiwan. And the semi-submersible floating platform design and the dynamic modeling will also be developed. And the question is in Taiwan we should have our own new platform. And in this issue, we will cooperate with Soik Ship and the Ocean Industry Development Center is a research center in Taiwan. And we will cooperate together and to develop and to investigate if the new platform in Taiwan. And and in this project, we also would like finally we'd like to develop the innovative system dynamic cost simulation. And also the ballast design, system design, and the normal ballast control strategy will also develop, especially for the Taiwan Strait condition. And finally, we will compare different kind of the platform and input the wind and the condition of the in Taiwan Strait. So here is our first step result in this research. And in the sub-project 2, Professor Zhao, his expertise in hydrodynamic analysis and CFD. And the first in the sub-project 2 is to develop the hydrodynamic analysis of the floating, including the hydrodynamic coefficient calculation and the viscosity detecting correlation and the IO calculation. And also the seakeeping analysis will be developed in this project. And the extreme analysis of floating design, that means the extreme aerodynamic analysis and the stemming analysis of floating foundation will also be made in this project. And it cooperate with the sub-project 3, the motion analysis of the gravity-induced install anchor will also be done in this project. And in the sub-project 3, Professor Kaidong Ma is a new guy. We just come from USA to Taiwan. He's a new professor in my department. He has over 30 years experience in mooring an anchor in the oil and gas in Houston. And after his retirement, and we invite him to join our team. And now, actually, he is a very important people, I think, in Taiwan, especially for mooring and anchor for the floating in the future. And a co-PI is Dr. Yang, Shunhan Yang. He is also a new assistant professor. He just joined in the project of 50 megawatt of floating offshore wind in Norwegian and just contact and join in our team. So in this project, the floating platform design will be developed first. It will cooperate with SOIC. We will design a 50 megawatt semi-submersible platform, and also the final element analysis, vessel stability, and the weather analysis, and also the dynamic motion analysis. Yeah, and the other issue is the mooring system. That's, as I mentioned, the Professor Katie Ma is expertise in this area. So the mooring analysis and the design will be another key point in this research. Including the mooring analysis, long-term fatigue analysis, and comparison of installation method, feasibility and planning of anchor sharing. Actually, what kind of anchor will be suitable for Taiwan Strait is just a question. So in this research, we will investigate and find if the gravity, the gravity induced anchor is suitable in Taiwan. As shown in this figure. And also the water depth from 50 to 100 meters actually is not so good for the cable, the sea cable. So the dynamic cable will become a very important issue. So the analysis and the design of the distribution buoy and the allowable vessel offset and will be also investigated in this research. And in the last part is the tank test. In this research, we will have a tank test in NTU. And Professor Jiba Tsai actually is over 30 years experience in the tank test. So in this research, we will have a scaled down model tested in the tank in NTU. And some criteria of floating offshore platform is the first is the platform should be survive under the typhoon weather condition in Taiwan Strait. And the second one is to minimize the motion under the normal operation condition to improve the electric power generation. So here you can see the first in the research we will use the IEA 50 megawatt as the first model, and after that we will have our own platform, and also for the 50 megawatt wind turbine. The test condition and the procedure here you can see, including the measurement of the wave, center of gravity, and the moment inertia of the model, incline test, free decay test, and the sea keeping test, and the IO will be calculated by the sea keeping test, and to predict the motion of the full scale model. And then also the performance of the active and the passive anti-motion device will also be evaluated in this research. Okay, what's our next step? Actually, as you see in the previous slide, in the phase 3, actually, floating offshore wind were also used in Taiwan. And in view of our today's status of offshore wind local supply chain in Taiwan, you can see, especially the foundation, the foundation manufacturer actually they get the order, but they have no time. They have less time to learn. So for not only for the wind farm supplier, but also for the local supplier, both are under high pressure. But for the floating offshore wind, we still have time. By 2026 or by 2030, we still have some years to prepare. So it's also our the goal of the research is actually it's a pioneer project in Taiwan, and in compare with Japan and Korea, actually we know in Taiwan we are a little bit late, but now we start to promote the floating offshore wind. Actually, we still have some time. The first is to promote the local supply chain for the floating. It's also the reason why CSPC now they're active to join to develop the floating offshore wind supply chain in Taiwan. CSPC is a potential local supplier for the platform and the mooring anchor. Yeah. The next one is I think it's just similar to the talk in other. Yeah, the test site is one or two turbine in Taiwan offshore wind farm should be promoted first, because the local supply chain, the component, and the subsystem, and the full scale model should be tested first to confirm the feasibility and to verify the performance. And after that, a demonstration project actually is a small pre-commercial project for 100 megawatt to offer. Yeah, and finally the commercial floating offshore wind farm can be opened. So I think we were in the university side, we will help the government and also help the industry, both the local supply chain and also the wind farm developer to together to go forward to help the Taiwan to build the floating offshore wind industry in the future. Thank you for your attention.
Thank you so much, Professor Zhang, for that detailed presentation. And I think you've just taken the next step of what's happening in the industry at the moment. Although we're perhaps focused on bottom fix at the moment, and you actually foresee that in the next 4 to 5 years or 5 to 6 years, the need of developing floating offshore wind is essential to the industry, and also to cope with all the demands, of course. And of course, the World Forum Offshore Wind is very happy to be here in Taiwan and to be sitting alongside with you, and hopefully we'll get more action involved in regarding this prospect industry here. So during the professor's presentation, we've actually heard on numerous occasions regarding CSPC cooperation in their endeavor of the offshore wind industry here. So today we are extremely delighted and honored to have invited Mr. Mike Zhou, the Executive Vice President and Spokesperson of CSPC Corporation here in Taiwan. Mr. Zhou, thank you so much for joining us today at our webinar, and we are very excited about your presentation today. And so the floor is yours. Thank you very much.
Can you see my slide?
Yes, we can. Thank you.
And thank you first for the WFO invitation for this World Forum Offshore Wind. I'm Mike Zhou, Executive Vice President of CSPC. And today I will covering the company review and also CSPC's offshore wind map, and finally our facility and the capability. And first is our background. And our company was founded in 1973. And we are the largest shipbuilding company in Taiwan, and IPO in 2008, which is a world financial crisis. And that is the only one company have IPO that year. And over the past 48 years, we have delivered more than 700 ships in various ship types. And recently, CSPC also expanded business activity to offshore and engineering field. And the left-hand side is our company equity structure. And you can see that the government still take the biggest share, and except the individual investor is about 26%. And the right-hand side is from 2014 to last year, our turnover. And from the previous, you can see the turnover from 2016 to 2019, the turnover is quite low. It's because of the shipbuilding business not so good. And from this slide, you see in 2017, the shipbuilding is our main business. That will take about 98%. This year, and the shipbuilding only take about 20%. And from the government started to the indigenous project for the Navy and also the Coast Guard. And now the government project takes about 60%. And also CSPC also expand our offshore wind farm and business. And for this part, and this year also take about 20% of our turnover this year. And as I said that our core business is shipbuilding, and for the UK Royal Institute of Naval Architects, each year they will publish a significant ships of 100 ships each year. And from 2014 to 2020, and there are 7 vessels designed, constructed by CSPC on the cover page. And next, I would like to discuss about our human resources. We have 2 shipyards. One is in Kaohsiung, and we have almost 2,500 employees. And Keelung, we have less than 400 people in Keelung. And from the right-hand side, you can see our engineers, designer, and also some managing levels of engineers. We have more than 700 people. And this is our offshore wind energy business map. You can see we can provide foundation. And for the offshore wind, the corrosion, anti-corrosion is very important. We also have our subsidiary company, CSPC Coating Solution Corporation. And we also have a joint venture company, CDWE, and work also together with a Belgian company, Deme. We can provide the transportation and installation. And CSPC, we also have our own marine team. We have tugboat, we have a barge, and this year we will probably purchase 2 more anchor handling tug supply ships. And for this entire business map shows our intention for the offshore wind. And what can we do for floating wind farm? I think this year, MOEA BOE, Bureau of Energy, they have announced a phase 3 from 2026 to 2035. Total, there be 15 gigawatt floater, and maybe the wind turbine should be installed. And CSPC, for our company, we can provide the component, especially for the floater. And CCSC, we can provide the coating service. And we can, CSPC, we also have a team for the floater launching, because most of the floater will build in the building dock. So we can provide the floater launching, and it's very easy. And also CDW and the CSPC, we can provide the transportation, the turbine installation, and also the wet tow and mooring system installation from CSPC and also CDWE, hookup and the positioning, commissioning, and also the decommissioning of the floater. Next is our building facility. You can see the Kaohsiung Yard and Keelung Yard. And especially I use the red print, shows that the building dock of CSPC Kaohsiung, the length is 900, more than 900. The width is 92. The depth is 14. And each year, not counting to the commercial or the Navy ship, we probably can still provide 120,000 tons per year of steel structure. And this is the bird's eye view of Kaohsiung Yard. And you can see the main building dry dock. And this area can provide the giant block assembly. And we have a facility to produce a steel structure. We have 2 gantry crane, high pressure dust clean machine, and steel cutting conveyor, and a VOC treatment, an NC plasma cutting machine, and also the 1,000-ton hydraulic bending machine. The blast and painting shop, we have 9 shops, and also the super carrier to carry the heavy structure. And this is the floor plan of CSB's Kaohsiung Yard. And this picture shows that the phase 2, we provide the pin pile production. And this pin pile production line is a newly invested facility here. And we also provide six sets of the transition piece production area. And this key side, we can provide a very heavy load, a uniform load up to 30 tons per square meter. And this shows the load out of our pin pile. And this is a type of floater now have been tested either in demonstration site or the research project. And last month, the SOIC, Ship and Offshore Industry or R&D Center, they just announced a Delta float. And this Delta float is also very friendly production in our shipyard. And this is the estimated capacity to use our building dock, and like a wind floaters. And we can utilize this joint building dock up to 5 sets, while we still can construct our commercial vessels. And this size of the floater, probably the width is 80 meters something. For this distance, and we can estimate to provide 5 sets here. And in the meantime, we can also build a mega block here. And this is just an estimate. And in times we don't build the commercial vessel, the size probably can 10 sets of the floaters. And also I have to mention about the quayside height limitation range due to the Kaohsiung Airport in Shaogang. So after the launching of the floater, if it's not allowed to install the tower, and CSBC will find some other place to install the tower. And this is the bird's eye view of Keelung Shipyard. And the main floater probably will be built in Kaohsiung Yard. But for the anchor system, like a typical anchor or the typical anchor, Keelung Yard, they have the capacity and also the facility to support Kaohsiung and also the northern partner if the floater of wind turbine will be adopted by the developer. And thanks for your patience, and I will return the floor to David. Thank you.
Thank you so much, Mr. Zhou, for a very detailed and very specific introduction of the company. I think up to now, it may be safe to say that we are summing up the conclusion is that all these different companies are preparing for the next step for the floating offshore wind, whilst of course at the moment emphasizing on the bottom fixed solutions. But I think it's very important that we look forward and prepare so that we don't get caught off guard, and we make the best decisions once we get to the next stage. Speaking of moving on to the next stage, the next speaker, I think it's very exciting to share, is that we have invited JNB Energy Technology, Mr. Kai Tan, the CEO and co-founder of the company, just a very brief introduction for Mr. Tan is that originally the company wasn't involved in offshore wind, but very recently, in a couple of years, they have developed into their new business venture, and I think it's very exciting to learn about Mr. Tan's endeavor going into offshore wind. So thank you so much for participating today, and the floor is yours. Thank you so much, Mr. Tan.
Hello. Yeah, thank you for the introduction. It's my pleasure to attend this seminar. Yeah, I'm very excited about this seminar, and in fact, we are quite new for the offshore wind industry. Yeah, so every speaker in this seminar, I believe, are very specialists in some industry, and we are very open to want to have the opportunity to cooperate with everyone. Yeah, let me. Yeah, so I start from who we are first, and then everyone knows what Taiwan team wants to do. Yeah, in the past, I'm the CEO of the company. In the past, we focus in solar. I think for about past 8 to 10 years, I do the solar in Taiwan and Japan, and right now we do some change in the past few years. And there are some track record in the past. We have the first Google corporate PPA in Asia Corporation, and we have some deal with BlackRock, and we have some cooperation and co-investment with local pension fund for the solar project, and we integrate a lot of I think renewable business in Taiwan. I can have more detail in coming. So here's the news. The Google have the corporate PPA with us, and the right-hand side we have I think right now it's the biggest dual-use solar project in Taiwan, 123 megawatt project. Start construction, I think, in next month or 2 months later. And just like I mentioned, cooperate with the BlackRock in the past. So before 2019, we focus in solar, no matter ground rooftop, no matter floating and dual use project. And since 2020, we invest the Tianli, so step in the offshore wind business. And this year we set up the Taiwan team platform together with the other 3 players, and also investing. Yeah, let me go to the next page. Right now we have 6 major renewable business. Solar, of course, we are familiar with, and also the offshore wind business, and we have the wastewater treatment business, and biomass, and energy storage, and also the renewable energy retailing business. So our company is trying to build up the one-stop service for all renewable energy in Taiwan. Yeah, that is part 1, what we do in the past. And this, yeah, very pleasure to have the opportunity to attend the Taiwan team. So I believe everyone knows that Taiwan offshore wind resource is very good in the world. So the top 20 good locations in the world, 16 are in the Taiwan. So the increase of energy independence and the demand of green energy, that make the Taiwan offshore wind have good opportunity at this moment. And for Taiwan, phase 1 and 2, and right now the phase 3 rule already announced, so everyone right now is prepared for next year's meeting. So that's why we have the opportunity to build up the Taiwan team together. I think it's like what I really want to do for many years ago, because the first time I saw the offshore wind business in Taiwan, that's really amazing. But at that time, we are only doing the solar. It's very far away from our company. But like round 1 and round 2 passed, Taiwan's government let the Taiwan company have the opportunity to do the localization first, and the Taiwan people have the opportunity to learn and to see what's the foreign player to do the offshore wind business, to construct, to design, to develop all the process. So after round 1 and round 2, right now come to round 3. That's I really want to have the opportunity to cooperate, to group a team. It's all Taiwan's company. I want not only the supply chain is made in Taiwan. I want the people, the human resource, the design and development experience, all can learn and stay in Taiwan. And so that's why we set up the Taiwan team. There are 4 Taiwan company join together. And right now we want to do the Taiwan project first. And in the future, we want to step out of Taiwan to do like Japan, Korean market in the future. So that's the dream. And in the past, so right now I have the opportunity to make that come true. And yeah, we have the Tianli and YGG is a supply chain in Taiwan, and SI has a lot of experience in the past. So 4 of us set up the Taiwan team together. And our first project, we have the Formosa 4 and Formosa 5, and yeah, the name should be correct. The 4-3 are Formosa 4 and have fixed foundation sites. Will attend the bidding next year. And 4-2, that is the Formosa 5, just like the speaker just mentioned. Floating project are the future of the Taiwan, because the fixed foundation project is not so much. So next year, 2023, must have floating project attend the bidding. So here comes what I mentioned. Taiwan right now have the opportunity to train in the local people to accumulate the energy. So here are the picture of the left-hand side. The Tianli factory right now is already settled. So the first place coming soon. And right-hand side picture are YGG's picture. Right now it's under construction. And yeah, YGG supply to no matter Vestas and Siemens casting. Yeah, so Taiwan team's vision, we do want to help to trying to help to develop the people to know the knowledge, design, and local people talent to build up the Taiwan team. And the most important, can lend the Taiwan people to the Taiwan project, and then bring Taiwan supply chain out of Taiwan. So it's our Taiwan team really want to do. So yeah, I believe we still have a lot to learn, but yeah, in the future, wish to have the good result in Taiwan and other country. Yeah, thank you.
Okay, thank you so much, Mr. Tan, and thank you for that introduction, and also sharing the goals and missions of the Taiwan team, especially bringing up to speed for the localization part. And I think that brings up to one of the main points of why we have this webinar, is to provide a platform to share where the opportunities are. And I'm sure as set up for the Taiwan team, this opens up so many doors to different opportunities for collaborations. And eventually, once we have the localizations set up, I'm very certain that you have great opportunities to out of Taiwan to provide services elsewhere. To touch on the great wind conditions here in Taiwan, of course, I'm sure the audiences here are very familiar. We have fantastic winds measuring up to high 11 meters per second, and that's almost all around one. At low, perhaps it may be a high 7 meters per second. So that's very favorable. Offshore wind, and obviously next step perhaps onto the floating offshore, opening up lots of business opportunities. And speaking of business opportunities, and I think it's very important now to introduce a colleague from us from TIER, that would be Mr. Xu. So TIER is short for Taiwan Institute of Economic Research, and Mr. Xu is the team leader there. Executing quite a few different government projects. We are very fortunate to have Mr. Xu online with us to share on his findings and hopefully share different insights of what we may expect of the offshore wind industry here in Taiwan. So thank you so much, Mr. Xu, and the floor is yours. Thank you.
Thank you, David and WFO. And can you see my slide?
Yes, thank you very much.
Yes, okay. Okay. Hello, I'm Wallace. I work for TIER and mainly responsible for offshore wind. TIER is a more than 40 years company and provide consulting service for government, private enterprise. Today, I will show you my understanding about the promotion of floating offshore wind industry in Taiwan. As you know, global floating offshore wind was in full swing. There were 68 projects in progress worldwide, and investment amounted to $63 billion. Especially floater and marine systems are the most investment potential in Asian markets. It will drive the development opportunity of the traditional component material supply chain of subsystems. The challenge for floating offshore wind is not the size of the unit, but the improvement of competitiveness through technological advancement and reduction of construction costs. According to Quest FWE report, comparison of various regions, we can see that floating wind is competitive in the Asian market in terms of medium and long-term market development, nevertheless cost of electricity and supply chain investment. About our policy, Tier 1 and Tier 2 are in progress and ready to enter Tier 3. Recently, our government BOE announced the zonal development rule. 10 years from 2026 to 2035 for 15 gigawatt are released. About developer selection, it will focus on technical capability, financial capability, localization, and bidding. Especially localization will be a crucial point. More importantly, is that a floating type added to the localization extra point. About potential development for floating wind in the Taiwan Strait, the industry evaluates to avoid sensitive areas and consideration of power grid capacity, water depth, environment, and submarine geology. Potential sites located in the cities of Hsinchu, Miaoli, Taichung, and Changhua. Especially Hsinchu and Miaoli, the water depths range from 50 meters to 100 meters. The wind energy density is the highest in Taiwan. We have the development of Taiwan floating wind issues now. I summarize the focus of 3 major industries concerns. We know that floating and fixed bottom are completely different technologies. due to the high cost and risk of floating wind. The first one is economic incentives of policy support. The second is demonstrate that, which the industry concern is what the approach to demonstration, how much capacity can be installed, what's the incentive mechanism, who can take precedence. And the third is local supply chain. Many suppliers want to enter the floating wind market, but they don't know what's the gap and how is the gap. About localization of mooring system issue, different from previous use of chain or steel rope in mooring, more and more applications are being explored in artificial fiber material. Nylon and polyester have been used in cage culture and also can be used in mooring system. Irony, HMPE, UHMWPE are materials that are currently of interest of domestic industry players and hope to enter the mooring system market. About localization of broader issue, for every 1 megawatt increase in offshore wind, the steel structure will increase the amount of steel by 300 tons. It will increase the cost of construction, so perhaps concrete can be used to reduce the cost of steel and increase stability. The ratio between concrete and steel of the floater quayside with high capacity, which are the local industry concern. With the clear of zonal development and selection rules, and the commercial value, scale, and market of floating wind becoming more and more clear, this is the best time for Taiwan to invest in floating wind and commercial deployment. It's just less about development of floating. We can focus on the development and breakthrough of underwater technology through international collaboration. Finally, it will drive the development of domestic supply chain and O&M service. Okay, thank you for listening.
Thank you very much, Mr. Xu Wallace, for that very detailed presentation. I think in Taiwan, there are a couple of not-for-profit organizations that it's very important to keep in mind, and one of them is definitely TIER, as they execute and does research in various fields, including offshore wind. So if you like to have more in-depth market research information, Mr. Xu will be a fantastic contact person to liaise with. So thank you so much once again, Mr. Xu, for that. And if we talk about offshore wind, and of course we cannot forget Siemens Gamesa Renewable Energy, as they play a fantastic role, a very important role here as well, with all the different companies building up to this wonderful industry. And today we are very delighted to have invited Mr. Erhan from Siemens Gamesa, the head of certification and engineering, to share with us this insight of the industry here in Taiwan. Just a friendly reminder to all the other speakers, if you'd be so kind to kindly mute microphones if you're not speaking. During Q&A sessions, we'll be more than happy to invite you to switch on your microphone again. Thank you so much. Mr. Erhan, it's a pleasure, and we look forward to having your presentation with us today. Thank you so much. The floor is yours. Thank you.
Yeah, I should unmute. I hope you can hear me now, and I hope you can also see my screen.
Yes, certainly. Thank you.
Yeah, thank you very much for letting me present here today at the World Forum with the topic of unlocking potentials for offshore industry. A lot of things have been mentioned already in the previous presentations, and that is also a bit on those things that we will actually embark on and go forward with. What I will provide to you today is basically a brief outline on where Siemens Gamesa has been standing in leading the offshore wind industry, and how we actually also want to take it forward in terms of leading the future of the offshore wind industry in these new markets, and also in particular in Taiwan. We will start off with telling you a bit about where Siemens Gamesa Renewable Energy stands as of today, where we were coming from and where we are actually heading to, and what we are actually then basing this technology upon. We are a wind turbine producer, manufacturer, and provider to the market, but we are also heavily involved into all these other research activities from where we have learned about from the previous speakers. And then finally, I will provide you a few impressions of those items that we currently work on with leading or for leading the offshore revolution into the decades to come. And you will recognize in a few moments what I will mean when talking about decades here. But starting off, introducing who Siemens Gamesa is, where we come from. And the company, as you all know, is built up on 3 business pillars that are actually strongly positioned in the market. Whereas in the offshore business, we are obtaining the market leadership role, and have been from the very first days of offshore, and will be continuing to push forward in holding that market leader position. We are very well positioned here with a strong order intake and a strong order backlog, but also with the outlook into the industry, global industry, and also into the APEC region industry. We see that we will be able to actually hold that position. On the other hand, in the onshore business, we are also well recognized in most global markets. And with the new products, larger products being launched now and being available to the industry, we also see that this will remain a very, very strong market and market segment for us. The service side, on the other hand, is also kind of profiting from a significant growth in the offshore industry, where we are reliable to act or are actually able to rely on significant experience over the recent years, and also the infrastructure and the principles and practices that are also very important for making this become a very effective and efficient business. Going forward, I'd like to outline to you a bit on where we were coming from. You might remember some 30 years back in 1991, we were actually installing the very first offshore turbine in Danish waters. At that time, that was a very small turbine with only about 450 kilowatt, and in a project that was comprising the amount of 11 turbines, we were then kind of running a project of 4.95 megawatt. The rotor size of that turbine was as small as 35 meters at that time, but it was the very first one, and it was actually laying the groundwork for every single offshore wind project that was then following thereafter, whether it was then supported by Siemens Gamesa or by some of our competitors, but it was actually building up and allowing for building up this entire offshore wind industry, and then with that providing the opportunities that we are actually talking about as of today. When we then look at where we are as of today, then there is a tremendous difference to be seen. Today, we are talking about projects that actually comprise 1.4 gigawatt. And so to that extent, that is a tremendous difference to what we had in 1991. We have, as of today, installed 1,200 of the direct drive offshore turbines. That is actually the backbone that we rely on, and that I will also introduce to you in a second. And we have brought the levelized cost of the energy is so far down that as of today, in particular for those established markets in Europe, the projects are running on as a subsidy-free projects. So basically no longer financed by kind of market entry subsidies. That is, of course, not yet applicable for all markets, but this is also a tremendous achievement that came up with the significant growth of the offshore industry and also the significant growth of the products that we were providing to the offshore industry. Today, we have about 18.4 gigawatt of power installed to the industry. But when then looking out into the future, where we still have about 234 gigawatt to be installed by 2030 on a global scale, then this is actually also outlining what the market is that we are talking about. So going forward, this is about showing to you what is actually the backbone to the offshore industry. And this is actually the real revolution behind the significant growth that we have seen over the recent years. In 2014, we started the standardized production of the direct drive, and this is actually the backbone to our production since that time. The direct drive technology is offering a lot of advantages in respect to the scalability and the lightweight, and was actually the significant contributor to bringing the levelized cost of energy down. It's not only that it is optimal for installation due to the design principles of the turbines itself, but also the fact that it is built upon a number of, or a significantly reduced number of moving parts. It is increasing the reliability, it is reducing the cost in itself, and it is also reducing the cost for maintenance, which is an important aspect for the operational costs of a wind farm. With that, we have been celebrating the installation of the 1000th unit about 2 years ago. And as of today, we have more than 1,200 units of direct drive technology installed to the market, including those turbines that we installed here in the Asia market, in particular in Taiwan. And there are more than 17 gigawatt that we already have under installation or are to be installed. So that is actually the outlook for the direct drive that we as Siemens Gamesa are looking upon. The next big turbine is already underway. It is considered to be installed here in Taiwan, and actually it will be the very first production turbine that will be installed here in Taiwan in a few years. The prototype will be ready by the end of the year. Technology is basically scaled up from the smaller versions that we had before, and that are actually in the meantime certified and also rolled out into projects. This one is now being erected in Denmark. Tower is installed, and as mentioned, the prototype will be completed by the end of the year, with then enabling us to close the certification aspects of this turbine and then bringing it forward into production and into installation over the next years. With this direct drive portfolio, Siemens Gamesa is bringing the proven technology to the APAC markets. And it is not only that we bring the turbines here, it is also that we bring a lot of the kind of supply chain and manufacturing chain into the markets to support the local, the buildup of local competence and local practices. All of these turbines are actually type approved in line with the T-class, the Typhoon classes, as some are saying, and are actually all able to accommodate the local codes and standards that apply here in the Asia market. And actually these projects are then also being taken forward into the markets around, be it South Korea, as the next market that we actually develop here from the Taiwan platform, from the Taiwan offices, or also talking about Japan, where we are heavily active in kind of supporting projects based on the older products as of today, but also looking into the new features and the new products being brought out. And of course, Taiwan is playing an important role here in respect to developing these markets, developing practices for these markets, and then actually bringing that across. Then leading that over into a few thoughts and illustrations on what it actually means leading the offshore revolution going forward. If you take a closer look at this picture, you see actually the Winderby turbine that I was showing to you some pages before on the lower right end. And this is actually scaled up, and here you can actually see the 30 years of evolution that we have been through over the past decades and what this is actually leading to. The Winderby turbine at small scale on the right hand, and the turbine that we consider for the Hai Long project as the first industry installation on the left hand. And this is actually what happened over the recent year, and that is the recent years. That is the revolution that we have seen, and what you will now see on the next pages, that is basically about the revolution that we will see over the next years. We can of course expect that this will no longer be on the scaling of turbines. Of course, there will be an upscaling of the turbines, but it will not be anymore in these kind of relations as we see it here from Winderby to Hai Long. But it will be about growing the business in Asia. It will be about growing into new markets, and that will not be only Taiwan or Asia. It will also be other markets all around the globe. But the cooperation that we will then have within the company will be relying on the integration of the competences and the resources and the opportunities that we will have developed by the time here in Taiwan, be it that kind of factory that we have in just recently opened in Taichung, be it about all the competencies and the people that we have hired into the company already, be it about the local competencies that we have here for cooperating with the markets around, or be it product management, project management, sales, or engineering competences that we are currently developing and that we will be continuing to developing over the next years to come. It is very important for us as a company to actually integrate all of these competencies on a decentralized basis. And I can tell you from the certification and regulations point of view that we are already today utilizing that also for projects on a global scale. So that is the thing about growing into new markets, growing into Taiwan, growing even further here in Taiwan. The next thing is a revolution that we heard about a few things already during some other presentations today, that is about floating. You know that Siemens Gamesa has been active in supporting a number of floating projects with different floating concepts in the past. This will continue. A number of these demonstrator projects are on the horizon or are actually ongoing. And to that extent, we will be looking forward now into kind of taking our learnings from these demonstrator projects and then taking those forward into these pilot projects that I think were mentioned by RWE earlier on in the presentation. These projects that we work on as of today are important to learn about the floater controls, but it's also, and that's probably the most important part, to learn about how can we actually design these floaters so that they actually can be built at reasonable cost. So cost cutting, cost reduction, bringing costs down is an important part of these different investigations that we are supporting with partners on the floating part. But what is also most important in this regard is that the floating platforms might at some point of time, if the costs are low enough, actually also become an attractive alternative to jacket foundations that we as of today use for deeper waters. but also for these waters, on these applications, we might then in future already rely on floating platforms. The next real revolution is actually shown on this picture over here. This is a picture from an island operation for hydrogen production in Denmark. What you see here is one of the very first plants where Siemens Gamesa is operating a turbine that is off-grid, so on an island mode, and is producing hydrogen that is then sold to public applications in Denmark. This actually shows that the industry is not the industry, that the technology is working and can also be scaled up. There are a lot of learnings to be taken from this, but the important part here is that we see that we need to drive this kind of hydrogen revolution forward in order to support other industries that heavily rely on heavy demands of energy. And in order to support these industries in their kind of decarbonization commitments, I think it is very important that we also continue to actually develop further solutions for the hydrogen industries. The final picture showing here is a bit difficult to interpret on what this actually shall be, but you might have read in the news some weeks ago that Siemens Gamesa has actually introduced the recyclable or fully recyclable blade, and then also aiming at introducing the fully recyclable turbine over the next years to come. This blade is now in production. It has been tested. It is based on a new kind of resin formula that has been developed with industry partners and academia partners. It is a proven concept. In the meantime, we have produced, I think, about 6 to 10 blades in the meantime, with more to come. Also, the kind of recyclable or recycling process has been tested and is working. The aim here was to actually allow for separating the resin from the other materials that are used in order to actually then allow recycling the materials even further. It is working. It will be brought to the industry. It is already brought to the projects, and you will see this kind of revolution coming up in the next wind farms that will be subject to installations. So, of course, there is a step-by-step process. We need to grow the capacities for the materials on the one hand. It can be applied in the standard kind of molds and forms that we use as of today for building the blades. So in that regards, we do not necessarily need to invent a lot, but this is actually where we take it forward. And this is something that we are really proud upon, because this was one of the last major challenges that the industry was facing and has now found a resolution. This is also something that you will then certainly see for Taiwan, and where we will then also see other opportunities coming up over the next years to come, where Taiwan will then also participate in supporting this revolution and these opportunities of taking innovation forward. Siemens Gamesa is committed to actually support this going forward, is committed to actually grow this to industry size and support the industries all over the globe, and Taiwan will play an important role in that. Thank you very much for letting me present to you.
Thank you so much, Mr. Heng, for that presentation. It's always very exciting to learn what Siemens Gamesa is doing recently, and especially learning about the revolutions that the company has pushed for technology. That's very exciting to learn, and we look forward to that. And I think up to now, the panel has gone through a very interesting stage where we actually talk about the economic impact, or perhaps the industry itself in a macro sense, and then focusing down to Taiwan, especially by RWE and WFO, Mr. Gunnar Hesek and Mr. Chong, and then followed by a very academic, very detailed presentation by Professor Jiang from the NTU, of course, CSBC Corporation on very factual sharing about what the company is doing and what they're about to do. and also then JMV, the very interesting transition from solar to offshore wind, and about the Taiwan team and going forward from there. And then very interesting research, market research sharing from TIER, and of course Siemens Gamesa. And I think with these different projects, one of the very important aspects, it's very good in terms of pushing technology itself, but also from management, project management point of view, financing plays a very important role here. And for the final two speakers, we're going to be talking about risks and financing, and it's very, very exciting to have invited Mr. Stephen Ho to share with us, as he has first-hand experience with offshore wind projects in terms of financing. And I'll not let the cat out of the bag. I'll let Mr. Ho to share with you his experience. And thank you so much, Mr. Ho, for joining us, and the floor is yours. Thank you.
Hello, can you hear me and see my screen?
Yes, we can hear you and we can see your screen. Thank you very much.
Thank you, David. Thank you to the World Forum Offshore Wind who gives me this opportunity to share my experience in financing offshore wind projects with you. It is my honor to be here with you today. My three-part presentation. Switch my screen. I'm sorry. I can't see my own screen, so. Well, anyways, I can't see it, and do you see like a table of content right now?
Stephen, at the moment, I think we're seeing page 1 of your presentation, first page.
So this is a table of content, correct?
No, we're actually seeing the first page, the front page of your presentation.
Okay, this is a table of content.
Not yet.
I am so sorry.
It's okay.
I'm going to stop sharing. Can you send me the link for the yeah, now you can't see my screen, right? Can you send me that? Can you send me the link so that I can invoke my my PowerPoint again? Okay.
No problem. There we go.
Okay. Well, somehow I can't see my own screen, but it doesn't matter. Okay. So this is the first page. So the second page, this should be the second page. Is it the table of content right now?
No. Okay. Maybe what we could do is I could share your presentation from my laptop. Do you think that will work for you? And then you can let me know. You can let me know if I have to go to the next slide.
Sure. I just need to see my own screen.
Of course, no problem.
I can see this is my This is a table of content, correct?
Now we actually sharing. I think you're seeing my screen.
Oh, okay. So you have your table of content up, right?
This is the table of contents.
Okay, good. Okay, good. My three-part presentation today will cover first an overview of the offshore wind opportunities in Taiwan, and second, how offshore wind projects have been financed in Taiwan to date, and third, the future development of offshore project finance in this market. Next page, please. So I am seeing actually now my own screen, I think. Green energy policy since 2016, is that correct?
Yes, I think this is my screen that you're seeing.
Oh, is it yours?
Yes.
Okay, all right. Well, coming back to Taiwan then, the nuclear drive, which is a cornerstone of the green energy policy put in place by the Taiwan government in 2016, targets to generate 20% of electricity from renewable energy, up from 5% back then. A critical enabler for this renewable energy initiative is to offer basically to developers in the form of a 20-year feed-in tariff power purchase agreement with Taipower, the government-owned electric power utility company. While solar and wind powers are both promoted, offshore wind is attractive to developers, investors, and financiers around the world, as the Taiwan Strait is considered as one of the most the best resource areas for offshore wind. The planned capacity of offshore wind farms by 2025 has been raised from 3 gigawatt to 5.5 gigawatt, with the most recent Ministry of Economic Affairs plan actually targeting to install an additional 15 gigawatt in 10-year period from 2025 to 2035. So assuming a project cost of NT$ 180 million per megawatt, an exchange rate of 28 NT dollars to $1 and a debt equity ratio at 75%, the installation of a total of 20.5 gigawatt translates to actually a US dollar equivalent of $100 billion project finance loan opportunity. Next slide, please. Let's take a look at the instruments and sources of offshore wind financing. There are many opportunities for international developers, suppliers, and financiers to provide capital and expertise in working with domestic banks and investors to put together financing packages to build those offshore wind farms off the coast of Taiwan, as projects are required to source at least 20% of the debt from local banks. The market has attracted an array.
My apologies, Stephen. I just want to double check I'm on the right screen with you. So we started off with this page, and then the following page is back to table of contents. Is that correct?
No, it's one more. Going forward is financing offshore wind projects in Taiwan to date. It starts with equity.
Okay. Yes. Okay. Certainly. Okay. Thank you.
All right. Thank you. So the market has attracted an array of reputable offshore wind developers and strategic investors from Europe, North America, and Australia, with notable names such as Ørsted and CIP from Denmark, WPD from Germany, Laughlin from Canada, and Macquarie from Australia. They work with other strategic and financial partners from Japan, Thailand, Canada, France, etc., to provide equity capital, which invigorate the offshore wind market here. There are also local equity providers such as Thai Power, China Steel, and a number of local insurance companies and private equity firms. The liquidity of the anti-dollar loan market has been very strong in Taiwan, and a couple of offshore wind players have raised funds via the corporate loan route. These loans are mostly provided by domestic banks with recourse to the borrower against the credit standing at the corporate level. The tenors of these type of corporate loans are usually capped at up to 5 years. As an alternative to corporate loan lending, project finance deals have been ushered in by international banks with a vast experience in offshore wind projects in Europe. These project finance loans are highly structured to mitigate the inherent offshore wind project risk, as payments for interest and principal come only from projected cash flow from the project, and it's in most cases without recourse to equity investors, and over a long period of time, say between 16 to 20 years, within the contract period of the 20 years of power purchase agreement. Typically, the commercial risk of these loans are shouldered by commercial banks and export credit agencies. Funding could be provided by commercial banks and insurance companies. In the event that there are shortfalls during the life of the loan, incremental financing would be needed from equity investors and/or lenders. Both international banks and developers have issued green bonds in the anti-dollar market to fund offshore wind projects in Taiwan as well. The first from these two camps are SocGen, a French bank, and Ørsted, a developer from Denmark. Just to give you an illustration of actually the cheap financing available from Taiwan, the first green bond from SocGen issued in 2018 raised a total of NT$ 1.5 billion at an interest rate of actually only between 0.85% to 1.65% for 5 years to 15 years term financing. Ørsted has also raised 2 green bonds along the same line. These bonds are examples of issuers raising low-cost financing in NT dollars and managing foreign exchange risk to support the offshore wind projects. The next slide, please. As offshore wind projects finance deals are highly complex and structured, there are plenty of roads for banks from the origination phase to closing, and during the long period over which the loan is paid down. In the center column of this slide, I list out 8 roles for the banks to play prior to closing of the project financing, project for financial advisory roles on the financing to pre-hedging banks. To the right, there are 5 more roles which would kick in at closing and thereafter, from the intercreditor agent to the final hedging banks for interest rate and currency swaps. Next slide, please. So there's a plethora of risk inherent in offshore wind projects. The risk profile of project changes over the project life cycle as the project moves from the development phase to the construction phase, when the risks are most critical, to the operation phase after the project is commissioned. 2 overriding risk factors are related to the project sponsors and the off-taker of the power purchase agreement. The ideal sponsors are reputable developers and operators with technical expertise to complete the project on time and within budget. Equally important would be the ability to deal with difficult situations when there's a fund shortfall. At these moments, lenders would look to them to continue to support the project with the operational experience and financial resources, albeit that the project financing is signed without recourse to them. In case of Taiwan, Taipower is considered a high-quality off-taker with high credit standing. Other off-takers will be evaluated the same way. In the table on this slide, I've put the risk in 4 categories, with the second to the 4th category mapped onto the risk incurred during the 3 stages of the project life cycle, from the development stage to the construction phase, followed by the operation stage, and the corresponding risk takers and also their considerations. I put wind in the first category, as wind is the protagonist in our discussion today. The basis of all wind power projects is good wind resource historical data. However, one would not want to have actually too much wind during the construction stage before COD for obvious reasons. After COD, what comes to my mind is the famous line from a classic song from Queen, one of the best rock bands which sprang up in the 70s. Here, in memory of Freddie Mercury, please hum this line in your brain. Any ways the wind blows doesn't really matter to me and to me. Please go to the next slide. Now, in the next 3 slides, I will summarize select key information of offshore wind related bank financing deals for you. The only 2 deals have been raised to date at the corporate level. One back in the early days in 2016 for Swanker, which is the local sponsor of the 8 megawatt Formosa 1 demonstration project back in 2016, which is a 2.5 billion NT dollar 5-year loan provided by 2 local banks, Anti Bank and Cathay United Bank, and a foreign bank, BNP. The more recent one is a syndicated deal raised by Ørsted in the mid-2019, with overwhelming response from local banks, which outnumber foreign banks by 13-2 out of a total of 15 participants in the loan. Most local banks are attracted by the investment grade rating of Ørsted. That's in stark contrast in the early days to the limited appetite on offshore project risk at the time. The next slide, please. So far, 5 offshore wind projects, each committed hundreds of millions in US dollar equivalent, if it's not in the single-digit billion-dollar US dollar equivalent range, have closed with 2 in the pipeline. This slide provides some of the vital information of these project finance deals. Now, one could note that the entry of additional sponsors to the cast of the original sponsors, as some of the original sponsors sold down the exposure to select strategic or financial investors. Another noteworthy trend is the increasing number of participant banks, including both foreign and local banks, since the financial close of Formosa 1, the first offshore wind project finance loan in Taiwan market. The project financing of the 30 megawatt Zongnam project with China Steel as the lead sponsor, which is in the pipeline. I understand this is currently in the general syndication phase, is underwritten by local banks exclusively. So next slide, please. When the bids for all these projects were submitted, no one could foresee the coming of the COVID-19 virus. While Formosa 1 was completed on time and within budget, the progress of all projects are being affected negatively by the pandemic. I'm serving on the board of a nanotechnology company called CNTech based out of Singapore, which makes ultra-high performance concrete suitable for offshore wind farm applications. Its plan for getting DNV certification has been pushed out for over a year because of the pandemic. In Taiwan, various offshore wind projects are experiencing delays and cost overruns for various reasons, COVID-19 being one. As a result, various sponsors have to address the forecast funding shortfalls with the project lenders. In the Yuning project situation, an incremental financing was put together in which 6.5 billion NT dollar was raised with the original syndicate with 2 additional banks as reported by Loan Project. This is a transaction just completed a couple of months ago. Next slide, please. In this last slide of my presentation today, I would like to share a few observations along the journey of developing offshore wind projects in Taiwan. It is encouraging to see the continuing commitment and the political will of the Taiwan government to support the development. We're also seeing participation of local banks in the sector, with some stepping up to take leading roles of some of the upcoming deals in the pipeline. Prompted by an amendment in the Renewable Energy Development Act in 2019, we also see the emergence of quality corporate off-takers for long-term power purchase agreements in addition to Taiwan. One notable name is TSMC, by far the #1 semiconductor foundries in the world, with over 50% of market share globally. It will be a very high quality, actually, off-taker for offshore wind farm agreements. On another note, various projects are encountering situation where reality deviates from original forecasts. Project funding shortfalls call for additional equity and debt funding. Ramification of such experience on the structuring and negotiation for future project financing are yet to be seen. Last but not least, the increasing localization of supply chain for offshore wind projects should bring lower costs to allow lower feed-in tariffs. However, it would be more demanding on banks with respect to a higher level of discipline in the due diligence and risk assessment process before the ecosystem for offshore wind projects become more mature towards 2025 and beyond. This concludes my presentation today. Thank you for listening.
Okay, thank you so much, Stephen, for that outline of the project financing in regards to offshore wind. And I think that brings up to a very good spectrum of what we should look out for and where to highlight when we undertake such a project. For the audience, I know you have actually sending me messages, comments to different speakers. Unfortunately, we are a little bit out of time, so I'll skip the commentary for now, and I'll move on to the final speaker, and that is by Marsh, risk manager. We have invited Mr. Martin Beck for the offshore wind and renewable energy practice leader for Marsh. And thank you so much, Mr. Beck, for joining us as our final speaker, and very excited to listen to your presentation. Thank you very much. The floor is yours.
Yeah, thank you very much, David. First and foremost, can you see my screen?
Yes, we can. Thank you.
Okay, great. Yeah, thank you very much. And good morning, good afternoon, ladies and gentlemen. It's always a pleasure to have the last slot in a 2-hour session talking about one of the most exciting topics, which is risk and insurance. But I'll try to keep the tension high and to speed up a bit in order to not delay too much and bother you for too long. So very, very quickly, who's Marsh? Where I'm heading the renewable energy practice here for Asia. Marsh is one of the leading risk and insurance advisors globally, and for good reasons, with obviously in focus on renewable energy, involved in projects around the world in 11 countries with a sizable number of experts, and supporting our clients on the right side to avoid CO2 emissions beyond 50 million tons every year, creating some 100,000 jobs and some million households provided with renewable energy electricity. What I want to do today is to quickly focus on some of the factors we see that drive a bit volatility and exposure within the energy transition, and I'll really very quickly run through these, cautious of time. We see 5 major areas we will need to see if we want to make sure we understand the risk of transitioning into a more sustainable power generation. The first is the energy transition itself, whereas no doubt we need to transition. We need to make sure that we stop the climate change. But what does that bring with it? It's on one hand, we need to make sure we are competitive. And we've seen some of these zero subsidy bids in the Netherlands. We've seen them in Germany, and I'm very sure we'll see them very soon in other countries as well. So there is competition, which means there's high pressure on reducing cost to be more efficient, because with cost going down, it will likely have a margin impact. And the question is, what does that mean in regards to our life cycle cost? Not just the construction cost and maybe the first few years of operation, but the 25, 28 years project operational life cycle cost. From technology side, we've heard already a lot from Rüdiger and CSBC on the developments there and the challenges we have. We need to have the massive capacities. We need to increase efficiency. We need to scale up. And that's not just turbines and foundations, that's cables, even transformers of substations, but also new technologies like floating. We heard about that, green hydrogen, battery storage, whatsoever. Siemens Gamesa is talking about the revolution. I would say it's a question of what is actually revolutionary, and to accommodate insurers' concerns, is it possibly just evolutionary? I think it's a mix. I think there are areas where we really need to think out of the box and try new things. Also like airborne power generations, we've seen that earlier. But some of the areas are rather evolutionary, where we can really base new developments on existing experience and historic data. Question always is track record, right? We will see new players entering the markets on both sides, the project owners and developers, but also the equipment suppliers and contractors. And very important at the end is that we make sure knowledge is transferred in a sustainable manner, that we don't face any larger issues in the future, which may have huge impact on insurability and bankability. Because banks and insurance, and I'm really sorry for that, are a crucial piece of the entire game in the energy transition. And we need to make sure that we transition in that sustainable manner and that we don't lose any of the stakeholders on the way. And defects obviously is a big part of that, where we may end up in insurance claims, and we've heard a lot about in the press releases in a couple of months from different components, where we may see larger defects in heights of hundreds of millions. That may happen once or twice, but if that happens too often, this isn't good. So I'll come back on that a bit later, how to overcome that challenge. Regulation, we heard a lot about that today as well. So regulatory frameworks, and what does that bring with if we want to develop these projects, if we want to attend bids, with permits to be given, where we've seen issues in the past where permits were not given, or where we had delays in the permitting process for different reasons. Localization, an important topic, an absolute must to sustainably transition, but also coming with some challenges. And I'm sure the stakeholders here in the call today are all very familiar with the challenges behind that. Power purchase agreements, and not just talking about Taiwan, but generally where we see power purchase agreements who do not come with a sufficient level of investment certainty. And the last point, political risks. Maybe not a big topic yet, but not sure if that may change in the future, where we may have more and more projects also with power transmission between countries, or cross-border transmission, and what does that bring in terms of political risks if the countries enter into any disputes or whatsoever. Still fairly new to the offshore wind industry is NatCat, because that's something the very mature market in Europe and UK is not aware of or not familiar with. And although we've been talking a lot about offshore wind in Asia, like in Taiwan or China, I think we are still in the kids' shoes of really understanding that. And that's not meant disrespectful. I know that the industry, and in particular the turbine OEMs, have heavily invested into that, and we fully appreciate that Typhoon type certificates are issued, but what's really missing is track record in real environment and circumstances. So this is something to really understand: do we actually underestimate or overestimate the exposures to the components, cables, foundations, turbines? I think it's a matter of time to see and to learn from that. The big topic for insurance is the accumulation or aggregation of risk, where we have many of the projects, and that's not just in Taiwan. We'll see a similar situation in once the projects in mainland China go more far offshore, and then obviously in Japan, where we also have the risk of tsunamis, where lots of the projects are in the same area, which means if there is a typhoon or an earthquake event, it's very likely that not just one project is affected, but many more. And that means for insurers, very often that they will have to pay a much higher bill than if it were only one project that is affected. The insurance market itself is a bit in a transition from, as I said, a more mature market in Europe with smaller turbines, more proven technology, smaller scales, into Asia, still a bit immature market, inexperienced or less experienced, I would say, and with a different set of risks, which also means we see the insurance itself transitioning from the immature market and now a more mature or hardening market, as we call, which means if you look into what you can achieve in insurance markets when you seek insurance for your project, it's different to what you received or what you were able to get 2 years ago. We see limitations in cover where insurers refrain from providing the same level of coverage they did 2 years ago. We see the deductibles, so the part of the claim you retain as the project owner or the contractor, significantly increasing, whilst on the other hand, the insurance capacity, so the overall capital spent by insurers into projects is reduced, mainly because of the accumulation with natural catastrophe risks and cost increase. So the insurance premiums you need to pay rise. And that's not a Taiwan specific issue, but a global issue, obviously with Asia with natural catastrophe risk, an even larger issue or bigger issue because premiums are much higher compared to European countries. So how do we manage that? How do we overcome these challenges? And there are some ideas we have, and that's basically where Marsh has heavily invested to better understand that and to be able to advise our clients. So we are an insurance broker, but we do really see us more as a risk advisor, which comes much earlier than the actual placement of an insurance product, to help the clients to manage risk in the most sustainable manner. And that brings me back to the life cycle costs. So to make sure that the project is profitable throughout the entire project life cycle, not just until the bid and then during development, 2 years construction and 1 year operation. That doesn't make sense. We need to make sure the project is profitable throughout the entire life cycle. So on the transition itself, we need to better understand what is actually the risk-bearing capacity. I think with regards to insurance in the past, the idea was insurance is available and very cheap. So we just insure no matter what, everything we can insure because it doesn't cost a lot. That has changed. So we need to better understand how do we actually allocate the risk. And Mr. O was talking about the different stakeholders or sponsors taking risk, being equity owners, the financiers, contractors at the end, insurers as well. So how do we allocate risk properly between these parties? Again, we need to focus on life cycle insurance cost. We understand, yes, you want to be successful in the auction process, so you need to make sure you have a relatively low and very competitive bid price per megawatt hour, but we need to make sure that this is enough at the end throughout the entire project life cycle. So how do we make sure this is the case? And the last point is a bit on predictability, which is very difficult, of course. I mean, if a client asks us prior to the bid, okay, what are my insurance costs in 20 years? This is very difficult to answer. We have obviously historic data, but who knows if they are really applying in 10, 15, 20 years. So for all of us, and that's also for O&M costs and everything, we need to find a robust business case and financial model where we can say this is how it's going to be to work, maybe with some sufficient buffer, not too much buffer, because then you may not be competitive anymore. And that's how we will be able to sustainably transition. On the technology side, I think the best way to mitigate risk is always the technology, not contracts, not insurance. It's the first thing you can do is technology. So what about contingency plans? Plan B. So if you are not able to navigate your own PowerPoint presentation in a webinar like today, what's plan B? Is there someone else who can share the screen? Right, that's contingencies. Spare parts. Does it make sense to invest a bit more money to save much more money at a later stage? Like, for example, substation transformers or whatsoever, where I know if I lose that component due to a major impact or a major claim, I know lead times are long, and I want to resume business very quickly. Always, obviously, to see what is the cost for that and what is the benefit from that. Contractors, of course, have to be a part of that risk through their warranties. And if we introduce less proven, unproven technologies, they may need to bear a bit more of the risk. Can't be just the developers, but it also can't be just the contractors. It doesn't work. They also have fairly small margins. So we need to find the right balance. How do we properly allocate risk through contracts? Track record, obviously, if there is any chance to involve experience and expertise, we should try to do that. It will always help. On the regulation side, we need to make sure that there is investment certainty. So what Taiwan has just done with changing, let's say, the targets and also the auction goals with 3 gigawatt each year from next year on definitely helps. Gunnar spoke about the break we have in Germany with 1.5 years nothing in construction, and the German supply chain has suffered heavily from that. This is something we need to avoid. Localization and partnership, I see this in very good development in Taiwan. You can always be better, but it's in a good way compared to other countries to make sure there is sufficient manufacturing capacity locally. And insurance may also help with regulation, like, for example, political risk insurance, non-payment insurance in case you have any issues with the offtake or whatsoever. On NatCat, as I mentioned, we need to gain experience. That's the most important thing, to better understand what is the actual exposure. Is it assessed? Is it less? Is it more? And then to take that into further consideration when we further develop technologies and installation concepts and O&M concepts. Contingencies, spare parts, where we can, we may think about that. So if we expect earthquakes in our area and they could potentially cut my export cables, why don't I introduce more export cables or put some export cable length on stock, so in case my cable is cut, I can quickly reinstate. And again, insurance, of course, is there to cover natural catastrophe risk. On insurance side, obviously, we also need to reconsider our approach. As I said, insurance is more costly and not available as in the past. So what we've done is we've challenged the standard EML approach. EML stands for Estimate Maximum Loss, so where we try to assess the worst case scenario in a project that could happen, because we do not really expect a total loss of the entire project being very credible. And there was a very traditional way of estimating that loss scenario, and we've changed our approach to a more probability-driven approach, which is much more, let's say, aggressive, and brings us to a much more accurate outcome of that approach, which means the sum insured we need to insure at the end, or the limit we need to insure at the end, is much lower. And that helps the client because he buys less insurance and saves money, but it also helps the insurers because they have more capacity left to be deployed to other projects. So it's an industry solution, not a project-specific solution. We've also worked on unlocking fresh insurance capacity, right? So we need to have more capacity available because more projects will come. Now, this is possibly an easy exercise because with the energy transition and the big offshore energy players coming into the game as well, like the Shells, BPs, Total Energies, and others, the insurance companies from the offshore energy market will also transition and they will bring fresh capacity. But we need to educate them because they have experience with oil and gas, but not with offshore wind. And many of you will agree offshore wind is quite a bit different to oil and gas. So we've taken that responsibility to make sure that the insurers understand our industry and work on that. And the last point is then again reduce cover, where in the past we were just buying everything because it was cheap and available. Now reconsider, do we really need to have that kind of cover, or would we be able to bear a bit more risk on financier side, owner side, contractor side? Because it makes more sense and it's more sustainable. And that's basically the end. Thank you very much.
Thank you so much, Mr. Beck, for that presentation. I think sometimes we tend to place risk management at the end, but we certainly are wide awake in discussing topics such as this. Big investments, and certainly it's very important to have risk management involved and planned during all aspects of the project management. Ladies and gentlemen, thank you so much for your time today. I would like to sincerely thank the Bureau of Energy from Taiwan, even though the Director General weren't able to attend our meeting today. And also all our speakers from all different companies and experts. Thank you so much for your time. And finally, our audience, I do apologize, we have run out of time for Q&A. If I may allow my colleagues to let me share my screen, I'll share my contact details on the screen. So for any audience who have any questions addressing to our speakers, please do feel free to put your questions directed to myself and let me know let me know who the question is addressed to, and I'll be more than happy to liaise and take it further from there. So finally, ladies and gentlemen, thank you so much for your time today, participating at our webinar this afternoon. Hopefully, you may find this webinar exciting, interesting, and be of benefits to planning in regards to penetrating the offshore wind business in Taiwan. So ladies and gentlemen, thank you so much for today, and I wish you a fantastic day forward. Thank you.
Thank you very much.
Speakers,
yeah, thank you.
Yes,
Bye-bye.
speakers, thank you so much. I think we've already lost a couple of them, but just for the speakers, do you think we can take a screenshot, a group photo? Do you think that's possible?
Sure.
Fantastic. Okay, so I think we need to let me quickly change the screen. Okay, right. I'm gonna go 3, 2, 1. I don't know if I think we lost Mr. Zhou. Mr. Zhou is out of the office at the moment. But anyway, I'm glad to have the rest of you. So I'm going to count to 3, and I'm going to take a screenshot. Okay. So 1, 2, 3. Smile. Excellent. Thank you so much. Oh, fantastic. Thank you so much, gentlemen, and I'll see you very soon. Thank you. Have a great day.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Bye.